This question is about the elements in group 2. Explain why the third ionisation energy of beryllium is much higher than the second. So the first thing you need to do is look up beryllium in the periodic table. And when you look up beryllium in the periodic table, you see that it is element, it's quite near the beginning, element number 4, which means its electron configuration is 1s2, 2s2. So removing the second electron, so the first electron we remove is from the 2s, and then the second we remove is from the 2s, but the third we've got to remove comes out of the 1s. So the third electron is removed from the 1s subshell, which is a shell closer to the nucleus with less shielding therefore there is a stronger attraction between the nucleus and the electron being removed, the outer electron. So this one would have a graph where we would see an increase for the first and the second, and then a big increase for the third, and then a little increase again for the fourth. So when we're in the same shell, we see a slight rise, but when we're in the new shell, we see a big rise. Magnesium reacts slowly with cold water. So when it reacts with cold water, like all reactions of group 2 elements with water, we get the hydroxide and hydrogen. But that one is a very slow reaction, whereas when we react it with steam, H2O gas, get a different reaction where we get the oxide and hydrogen. Compare these reactions in terms of the products formed, one similarity and one difference. So the similarity is both reactions, so it says in terms of the products formed, both reactions produce hydrogen. You maybe could say that both reactions produce a white solid, but the main thing is that they both produce hydrogen. And what's the difference? The main difference, the product MgO is formed with steam, but Mg brackets OH twice with cold water. The reaction of calcium with water, so calcium with water, similar to magnesium with cold water, produces the hydroxide and hydrogen. In terms of oxidation states, why this involves both oxidation and reduction. So we can see that calcium is oxidized. We know that because its number goes up. Oxidation state increases 0 to +2. What goes down? Well, the hydrogens, the oxygens are -2 in both things, but the hydrogens are +1, and some of them stay as +1, but some of them go down to 0. Hydrogen is reduced because the oxidation state is reduced. Oxidation state decreases +1 to 0. Now, when you're asked about using oxidation states to prove oxidation or reduction, make sure you work out the oxidation states and then link them to the terms oxidation and reduction by linking increase to oxidation and decrease to reduction.